we are going to talk about prime factorization. So first we have to know what a prime number is, and we have to know what the opposite of a prime number is. So prime number is any number that only has 1 and itself as the factors. So remember, a factor is what divides into it. So if we have a number like 2, we have 1 and 2 that divide into it. That is it. So is this a prime number?
1 and 2.
Is the number 2 a prime number?
So prime is like you can divide it equally, right?
It means you can only divide it by 2 numbers, 1 and itself. It's different from a composite number in that it has 3 or more factors. So an example would be something that has
like 1. You can divide 1 by itself.
No, so it has to have 3 or more. So 1, 2, 3, 4, 5. Let's take a look at these numbers. We'll just do 1 to 10. So what can divide into 2? Just 1 and 2. What can divide into 3? 1 and 3. What can divide into 4? 1,
1, 2, and 4.
Yep. What can divide into 5?
1 and 5. Because
Yeah. What about 6?
1, 2, and 6.
What about 3?
Well, you can also do 3 because 3 is 6.
3 times 2 is 6, yeah. What about 7?
7, 1, and 7.
That's it. How about 8?
1, 2, 4, and 8.
Yes. How about 9?
1, 3, and 9.
Yes. And what about 10?
1, 2, 5, and 10.
That is correct. So, of these numbers, you can write down the list, and then you're going to see, is it prime or is it composite? You don't have to write prime or composite. You can just write whether it's a P or a C on all of those, and then you can share your answers with me. So, what do you think 2 is?
When you go to the bathroom.
Yes.
But 2 is prime because it only has 1 in itself.
Yeah, so you can do this for homework. Okay, so a prime factorization tree is something...
I'm going to go to the bathroom.
Okay, you find 2 factors that divide into the number. So if we have 18, we have to find 2 numbers that divide into 18. For example, 3 and 6, or 2 and 9. We're not going to pick 1 and 18 because then we're just going to be left with 18 again, and our goal is to factor this out, so we don't want to use that. We want to use 2 other factors. You can pick any factors that go in and divide evenly into 18. So I'm going to pick 2 and 9. You can pick whatever you want. And then as soon as it becomes a prime number, you circle it. So this 2 is a prime number. We circle it. Now we ask, what are the factors that go into 9? So what divides into 9? 3 times 3. So we put the 3 on one side and we put the 3 on the other side. And then since 3 is a prime number, we circle that. So that is step 2. First step is to factor all the way down. Second step is to circle our prime numbers. And the third step is to write the numbers like this. So we do smallest number times the rest of the numbers. So this one would be 2 times 3 times 3. So for homework, you can do prime factorization of 12, 65, and 50. You're going to do the prime factorization tree just like I did. Now, the great thing about this is you can always check to make sure that you got the right answer by multiplying these three numbers or however many numbers you have. So we're going to do 2 times 3 is 6, times 3 is 18. If it matches the number up here, you did it correctly. If it does not, then you have to refactor it and see what happened. So that is how you do a prime factorization tree. Now, we have two things that we learned last year: greatest common multiple and greatest common factor and least common multiple. Multiple means multiplying up, and factoring means what divides into it. So an example of this is, what is the greatest common factors of 6 and 18? So you're going to list out what divides into 18 and 6, just like we did up here. So we're going to do 1, 2, 3, and 6. And then for 18, we're going to go through all the numbers. Does 1 go into it? Yes. Does 2 go into it? Yes. Does 3 go into it? Yes. Does 4 go into it? No, because 4 times 4 is 16. Does 5 go into it? No. Does 6 go into it? Yes. Does 7 go into it? No. Does 8 go into it? No. Does 9 go into it? Yes. As soon as you get to halfway, the halfway point of the number, which is 9, right? Then you close it off with the number, because we will not have any more factors that go into it. And I don't know if you remember me talking about this. Every factor has to have a match. I call it a rainbow. The only exception is when it is a double. So like, for example, 9, we would have 1, 3, and 9. So 1 and 9 would be a rainbow, and then 3 would be a rainbow with itself, because 3 times 3 is 9. Does that make sense to you so far, George? Okay.
Yeah.
Now you circle the greatest common factor. So 6 and 18 have quite a few. They have 1 in common, they have 2 in common, they have 3 in common, they have 6 in common. But we're looking for the greatest common factor. So I can see that it is 6, so I circle it. The greatest common factor of 6 and 18 is 6. So the opposite is the least common multiple. You're going to be multiplying up. So if we were to find the least common multiple of 6 and 18, we're going to do the opposite. Instead of dividing down and finding the factors, we're going to be multiplying up or counting up by 6 and 18. So I'm going to start counting up, and then look at what I see. Oh, there it is. The least common multiple of 6 and 18 is 18. So I circle it, and that is my least common multiple. Do you have any questions about that, George? Okay, so you're going to try to find the least common multiple of greatest common factor of 25 and 40, and let me know what you get.
Okay.
And then the least common multiple of 9 and 12.
Okay.
So you can do those now, and I'm going to start working on your homework here. So least common multiple of 3 and 9 and 9 and 15 for homework. And then for greatest common factor, you could do 16 and 20 and 25 and 40 for homework. Okay, how are you doing on the greatest common factor here, Mr. George?
Oh. The greatest common factor